476. We are talking about sequences. Sequences in math are just a set of numbers, and there's some kind of pattern between them. It could be like 2, 5, 8, 11, what's the pattern on this sequence? Plus 3. Okay, if it's an adding pattern, they call it an arithmetic sequence. And you could be adding negatives also, so it could be going like, yeah, it could be 11, 8, 5, you know, that's like adding -3. Arithmetic sequence is when you add the same numbers over and over. I could write this sequence. So the pattern is plus 3. So what we're going to do is like back up 3. So let's do, if I go backwards 3 from 2, 2 minus 3 is -1. So you start at -1 and then you just say plus 3 times n. And n just tells you the number, the term number in the sequence. So like this is the first term, this is the second term, this is the third term. So if I put in 1, I should get 2. So -1 plus 3 times 1 equals 2. If I put in 2, that'll give me 5. If I put in 3, that'll give me 8. So this is what an arithmetic sequence usually looks something like this. If you want to go up by 3, you just put plus 3 times n. The n makes it go up by 3 n times, depending on what term you're on. Okay, anyways, and then the other sequence, let's start small, I guess. Okay, so what's the pattern here? Yeah, times 2. So if it's a multiply pattern, they call it a geometric sequence. So, and if I back up 1, if I do 3 divided by 2, if I go backwards, that'd be like 1.5 or 3 over 2. And then I want to double that. So I multiply by 2 and then to the end, because it keeps multiplying by 2, right? So times 2 times 2 times 2. So you multiply by 2 n times to get the nth term. Okay, so if we plug in 1 here, for example, we should get 3. If we plug in 2, we should get 6. If we plug in 3, so on. All right, okay. And then there's some sequences that they're still sequences, but they're not in these 2 patterns, and there's no special name for them, like n squared. If I plug in 1, I get 1. If I plug in 2, I get 4. If I plug in 3, I get 9. 4, I get 15. Okay, that's still a sequence, but it's not like going up by 3, or this is like plus 3, plus 5, plus 7. There's no like reoccurring adding or multiplying thing that's going on here. So this is still a sequence, it's just not one of those 2. All right, okay. Let's do it. On number 1, find the first 4 terms of the given sequence and state whether the sequence is arithmetic, geometric, or neither. T sub n equals 2n plus. Okay, I guess I should have introduced that terminology too. So the value of t depends on what term you're on, little sub n. So if I say what's t sub 1, that means what's the value of t when you put a 1 in for n. Okay, or what's t sub 2? That's the value of t when you put a 2 in. Okay, and they said we need to find 4 of these. I guess I'm not going to make you write like all these t sub 3, t sub 4 stuff, but plug a 3 in, we get that. If we plug a 4 in, we get that. Okay, so the first one is 2 plus 3, 5. Second one is 4 plus 3, 6 plus 3, and 8 plus 3. So those are the first 4 terms in the sequence. Oh, and what kind of sequence is it? What's the pattern here? It's plus 2, so it is arithmetic. We're supposed to write that also. That's like my first example almost, except for it starts at a different spot. Alright. Now 3. 3 times 2 to the n. Dang, I must have... Somehow these like problems must be in my subconscious because this is the exact problem I chose earlier. Okay, so if I plug in 1, 2 to the 1 is 2, times 3 is 6. If I plug in 2, 2 squared is 4, times 3 is 12. Plug in 3, 2 to the third, 2 times 2 times 2 is 8, times 3 is 24. 2 to the fourth is 16 times 3 is 48. Okay, you kind of see the pattern before you even finish, but yeah, I accidentally made this one too. So what is the pattern? Times 2, therefore it is a geometric sequence. Okay, this one's a little messier. If I plug in 1, 1 over 1 is 1. 1 plus 1, dos. If I plug in 2, that would be 2 plus 1 half. If I plug in 3, that would be 3 plus 1/3. 4 plus 1/4. Wonder. Okay, and what kind of pattern is that? It's like plus a half, plus 1 1/3, plus, I don't know, some weird fraction. So it's not adding the same number. Is it multiplying the same value every time? No. It's like, this is like times 1.25, this times something weird. I don't know.
It's neither.
So it's neither. It's just still a sequence, but it's not. Neither of the above. All right. So if I plug in 1, negative 1 to the 1 is negative 1 times 1 is negative 1. If I plug in 2, negative 1 squared is 1 times 2. If I plug in 3, negative 1 to the third is negative 1 times 3. It's easy to see the pattern on this one. Negative 1 to the fourth is 1 times 4. Is that arithmetic or geometric? No. No. So what could you multiply to get from here to here? Negative 2, but to get from here to here, that times negative 2 doesn't work, so it's neither. All the arithmetic should look something close to number 1, and all the geometric should look something close to number 3. Number 9. Yeah, this one will get us. Trouble in paradise. Okay, it doesn't state it, but these are going to have to be radians because they put a little pi in there, so they must be returning 2 radians for their angles here. I kind of know what they are because I know what the sine function looks like. Like at 90 it's at 1, at 0, at 180 it's at 0, at 270 it's at -1. Anyways, so I don't really need a calculator. If I plug in 1, I get pi over 2, which is like 90, so that's going to be 1. If I plug in 2, I get 2 pi over 2 is 1 pi, which is like 180. I'll come out 0. I plug in 3, we're over here at -1. I plug in 4, I get 2 pi's, back to 0. Alright. Is that anything? The pattern is like -1, -1, +1, +1, so but it's not adding the same value or anything, so it's neither. But yeah, so on number 10, you'll want to change your calculator into radians to do that one. Okay, number 11, find a formula. Gosh, this is my exact problem. What the heck? Maybe, yeah, I don't know. Okay, so what's the pattern on number 11? +3. So do you remember what I said we're going to do? We're going to back up 1 step. So, wait, is this the problem I put up at the beginning?
Yeah.
It was. So if I back up 1 step, like back up 3, like -3, it would start at -2. Plus, and then we want to go up by 3. Or you could say we're going up by multiples of 3. So it looks like that. Let's go ahead and use their little notation. Put t sub n equals -2 plus 3n. So when you plug in 1 for n, it'll go up by 3. When you plug in 2 for n, it goes up by 2 3s. When you plug in 3 for n, it goes up by 3 3s. And that gets you the pattern. 8 4 2 1. All right, what's the pattern on that one? How do we get from 8 to 4 to 2? Yeah, divide by 2. So, to go in reverse, what would have come right before the 8? 16. So, we want to divide, there's a couple ways we could write it. We could use like a division bar. We want to divide 16 by 2 n times. Like once for the first time, twice for the second term, 3 times for the third time. If we divide 16 by 2 once, we get 8. If we divide 16 by 2 twice, we get 4. So, geometric terms like, oh, I didn't mention that. So geometric is when you like multiply by 2 over and over, but in this case it would be like multiplying by 1/2 over and over. I could have put times a half here. I wonder The book might have. You don't have to, but it's still a geometric sequence, even if it's going down. Let's see what the book put. They put 0.5, so kind of the same thing. All right, 15, 30, 26, 22. Okay, so what's happening here? Minus 4. Okay, so I'm going to back up 4. So what would come right before that is 34. And then I'm going to, what am I going to do after that? Minus 4n. It's a little bit warm. I don't think my house dropped 1 degree last night. From when I went to bed to when I woke up. It was the exact same temperature. Must be humid. It's probably. Alright, 17 is kind of the same. State whether this given sequence is arithmetic, geometric, or neither. Find a formula for t sub n, the nth term of each sequence. So kind of the same thing as what we've been doing. These are a little bit harder because some of them are not geometric or arithmetic, so they might pose a challenge. But 17 is not hard. Okay. So, kind of like the last one, right? The pattern is plus 4. So very similar to number 15. So if I back up 4, that would start at 13, and then I'm going to add on 4 times n for each in terms. Oh, is it arithmetic or geometric? This one might fool us. 8, 12, 18, 27. Okay, well, it's going up by 4, 6, 9, but is it multiplying by something? If you did 12 divided by 8, or 18 divided by 27, or 27 divided by 18, they all would come out as 1.5, or 3 over 2. So there is a common multiplier here. So this is actually, it might be hard to tell, but it is actually geometric. They're just multiplying by 1.5 every time. So, if I divide, to go backwards, 8 by 1.5, which would be like multiplying by 8 times 2/3, would be like 16/3. Kind of a mess. They used the fraction? Yes, they did. And then we would need to multiply that by 1.5 or 3 over 2 in times. Once for each numbered term. Okay, so that is geometric. Is it's like the bell to start the fight. Could have done that in history class the other day. Did I tell you about Roman telling me about it?
No.
Well, I have Roman and Emily in the same class. So Roman comes in.
Oh, she told me about this. That was so funny.
Explaining how, I don't know if I should be recording this, how, Timothy and Jaden, Landon and Jaden almost got in a fight. And Roman was like, Timothy was like, boom, and stopped it.
That's actually accurate.
And,
right after it happened, he goes, wait till Emily hears about this.
yeah, and he immediately came in and told Emily, he's like, Emily, you would have been so impressed. His muscles were like, Emily was like, and she always just ducks her head and waits it out. Okay, of course that's why it's lasted for months, because she reacts like that. Okay, anyways, yeah, I did this example too at the beginning. This is not like times anything or plus anything. It's a tricky one. These are just square numbers. This is 1 squared, 2 squared, 3 squared, 4 squared. Yeah, it was the example I did at the beginning.
Yeah, it's just like, couldn't it be 3 plus 5?
Yeah, but
It's not adding the same value.
it's kind of like adding odds.
It's still a pattern though.
Yeah, I think you could write it another way. I'd have to think about it for a second. So if we backed up 1, that would be starting at 0, so I guess we don't need that. So to add an odd, odds go up by 2. Would that do it? 3. Oh, that's 1 too big. Okay. 1, 2. No. That would need to be added on. I don't know. Maybe I'll go back and look at it. There are sometimes more than one way to write it. I'll go back and think about it. Maybe there's another way. 11, 101, 1001. Yeah, this one's kind of hard. Okay.
You put neither on that one?
Oh yeah, sorry, it's neither. So yeah, these last few might be challenging for us because they're neithers, which makes it a little bit harder. Any ideas on this one?
Is it multiplied by 10?
Almost. That's part of it. So if I did 10 to the n, because that would multiply by 10s over and over again. Because 10 to the 1 is 10, 10 to the second is 100, 10 to the third is 1,000, 10 to the fourth is 10,000. So this is a little bit off. How far off is it?
1.
So I need a +1. Yeah, you guys are in trouble in 22 and 24.
Keep doing with us.
Can you just help us roll?
So what is this, neither?
How about,
Neither.
I'll help you with 1 and I'll make the other one bonus. They are neither, yes. I didn't even write neither down on this one. I'll help you with 22. 24 is not that different. We'll make 24 bonus.
Really 1 to 20.
Well, you guys are gonna help me with this. Okay. So, as fractions by themselves, like 1/2, 2/3, 3/4, there's not much relationship there. But if you just look at the numerators, what's happening?
Up 1.
It's going up 1. So, do your Soccer celebration victory lap.
Yeah.
Runner. Like you're Messi and you just won the World Cup. Alright. So how do I represent 1, 2, 3, 4? Well, the first term has a 1, the second term has a 2, the third term has a 3. So that would just be n. On the first term, n is 1, so it'll be a 1. On the second term, n is a 2, so it'll be a 2. Okay, the bottom is pretty similar, 2, 3, 4, 5.
Plus one.
Right, it's just 1 bigger. So we could write it as n plus 1. '24 is kind of like that. Combination of stuff we've done.